Hello, my name is Robert. I'd like to show you this special machine that I built for making metal gears for clocks or other applications without the use of a lathe or a milling machine. With my background as tool and die maker, experimental prototype model maker, and engineering, I designed and built this with high quality materials. It is very portable. You can cut gears in your garage or on a kitchen table. Took me over 2 years to design, develop, and build this particular machine. It is very easy to use, easy to make tooling for cutting flat gears of any diameter or teeth. And you can stack up to 4 gears at a time, use 1 and 3 as a spare. As an antique clock, repairing was my passion. I found a great need for gear replacement for damaged gears. I also did clock repair for clock repairmen, making special gears for them also. This is a brief overview of the machine. There's the spindle, the cutter, and the fly cutter, all in one little shot there. This unit is very simplistic. You just have to grind a 1/4 inch tool bit to the shape of the addendum and a dedendum of the tooth. That's the part of the metal to be removed. The tool bit is installed in the fly cutting tool holder. This is the little motor for it. This is a 1/15 horsepower motor. And this motor drives a series of step cone pulleys. So I have about, I guess, 6 speeds. I probably run an intermediate speed. There's a view of the step cone pulleys. The motor drives the belt drives the spindle drives the arbor for the fly cutting attachment. This unit is fully ball bearinged all the way through. This handle here operates the cam that hits the cam follower, and this rocks the cutting unit in through the blank that you're cutting and returning for the next cut. As you notice, the spindle is ball bearing, the pivot points are ball bearing, the cam is ball bearing, everything is ball bearing that moves. This is the indexing handle. This what moves the blank into the cutter to turn up the true diameter, or the other way to go into the fly cutter to determine the depth of the cut. This is all operated by a Brown & Sharp 40-to-1 dividing head. I built this dividing head. It's miniaturized of the larger one from the Brown & Sharp 40-to-1 indexing head. As you can see, as I rotate the indexing head, that the spindle with the brass blank rotates. This in turn is, later on, I'll be showing you how to true up the diameter to a proper size. And then after the diameter is right, then you can start cutting the teeth. I have 4 plates that fit on the dividing head. And these plates will give you any amount of teeth you want to cut from 1 to 360. Here's a view of some of the gears that I had cut, and also some gear blanks that I just took off my bandsaw with a small hole in the center. Like I say, the preparation is very simplistic. You just cut a blank. It doesn't have to be really round. You can even start off with a square blank if you wanted to. And it has 6 arbors. You use the appropriate arbor for the proper size diameter gear. You want to give it as much support as possible where you're cutting it, although the impact on a fly cutter going through it is very nominal. This is a picture of the milling machine indexing from Brown & Sharp. This is in a machinery handbook. And I remember I had to take a course in this and using the slide rule. Anyways, the slide rule, youngins, that's preempted the calculator. All you have to do is look at how many teeth you want to cut, and it'll tell you what plank to use, what disc to use, and how many teeth to use. And you can also get that online. Okay, this is a continuation. I'm going to finalize the diameter. Changing the arbors is a very simplistic way of doing it. You just have a socket head set screw. You loosen the screw, pop out the arbor, and you find an arbor of your choosing.
Oh, yeah.
You get the proper arbor to support the gear blank that you're going to cut. It is that simple and that easy. The whole machine is built, designed, and engineered to be user-friendly.